AI alignment research focuses on guiding AI systems to follow human goals, choices, or moral values. A misaligned AI system pursues some objectives, but not the intended ones, established by humans. Basically, let's try not to build robots that will evaporate humanity. Large language models are still at the point of what might be called alchemy, and companies are running to build them without a real a priori sense of what the right design is for the right problem. What this means is that the creators of these language models, they don't know exactly why deep neural networks work. Companies are going fucking crazy putting money into them, more and more information so these models can learn new patterns and be better at doing different stuff. Basically, be super intelligent, and we don't know exactly how these things fucking work. Nice. So here we go, we continue with the best basic guide to understand ChatGPT, AI, LLMs, and other stuff, and don't get behind in the future. We can understand LLMs as the new computing paradigm. Think of LLMs as OS, operating systems. There are Mac and Microsoft, and we have an open source Linux structure that allows other OS to be created in that shared system of abstraction, readily available for the general public. The major disagreement between Elon Musk and OpenAI, a company that he helped start, is due to Elon Musk's initial desire of this company to be open source, similar to Linux. However, OpenAI has chosen a different direction. ChatGPT is only one model in a hungry and competitive industry. And as in the OS worlds, some models are open source and others are closed source. Closed source LLMs. ChatGPT from OpenAI, Gemini from Google, Bing from Microsoft, Claude 2 from Anthropic, in collaboration with Amazon. At the time of this video, where are you, Apple? Open source LLMs. There's a lot of open source LLMs, but the most known is Llama from Meta. How do these models work? We can divide the whole process into two stages or parts. The first stage, the training of the base model or generative pre-trained transformer, GPT. Let's get a little bit more technical here, but not a lot. The base model is composed of two files and a computer to run them. One that contains the text corpus, or the large collection of text data used for training the model. This data includes a wide range of text from books, websites, articles, and other written sources. And the other that contains the lines of code that run the neural network architecture that teaches the model. I told you this was going to be easy. Llama 2 70B. Llama 2 refers to a second iteration of the model, and 70B refers to the number of parameters that the model is trained on. In this case, there are 70 billion parameters. Wait, is there any difference between the corpus text and the parameters? The text corpus provides the model with a diverse and extensive set of examples of human language. It is kind of a zip file or compression of the internet, hundreds of terabytes of text, encyclopedias, etc. This allows the model to learn patterns, context, grammar, semantics, and various aspects of language from real-world text. Essentially, the text corpus is the raw material from which the model learns about language. The parameters are what the model learns as it processes the text corpus, with relationships between the words, the structure of sentences, the meaning conveyed in different contexts, etc. Let's call them the rules and patterns that the robot learns and remembers, so it can understand and create language on its own. In large language models like ChatGPT, there are billions of these parameters, and they collectively form the model's understanding of language. They're not the text itself, but rather the distilled knowledge and patterns extracted from the text. At the time of this video, GPT-4 has 1 trillion parameters, 100 billion words or text. To put it into context, the human brain has 100 trillion parameters. We're not that far. The more parameters, the more tasks the model can do, and the better it gets at doing stuff. The better the model gets at doing stuff, the more money it will provide to the company. The more money the company has, the more money they will invest into bigger text corpus and better models. And boom! Welcome to the new scaling LLMs capitalism circus. And again, remember, where there's money, there's progress. As I just said, we're not only living interesting times, but also witnessing a modern gold rush for acquiring top-tier GPUs. The rule of thumb here is simple. The larger the data and computational power, the better the results and accuracy of the model. It's a case of the bigger, the better, where size is a crucial factor. And you were expecting a joke right here, but what I'm going to do instead is kindly ask you to subscribe and give it a like. I really appreciate it. This is why there was little to no buzz about ChatGPT 1 or ChatGPT 2. We simply lacked the computational capacity a few years ago. The interesting part of all of this is how the model learns from the corpus text. The computational complexity comes in when we get those parameters. The magic is in the parameters. What goes on inside the neural networks to create this magic? The lines of code of the neural network architecture are understood by the creators. They know the structure in paper, and they know how to adjust and optimize these parameters over time to make the neural network better as a whole for the next word prediction. It seems like they don't know exactly how these parameters collaborate between them to perform that. The knowledge database is strange and weird. For example, it cannot be accessed in multidirectional ways, only in one direction. The model answers this question correctly. Who's Tom Cruise's mother? Marilee Pfeiffer. Good. But if we ask the following, who is Marilee Pfeiffer's son? The model won't get a correct answer. So to have an idea of how neural networks work, let's revise some concepts. Language modeling. I have some context. I will predict what comes next. The neural network is trying to predict the next word in a sequence of words. The input enters the model. The cat is on the, and the neural network understands that in the given context, the next word would be roof, with high percentage of probability. What happens is that predicting the next word forces the LLM to learn a lot about the world inside the parameters of the neural network. In our case now, the cat. All of this is happening besides understanding how to generate the language. The LLM has to learn about the world of the cat. What does it look like? What does it like and don't like? What forces him to do something or not, etc. The model doesn't parrot the exact extracts we have inside the corpus text in the neural network. It creates them. The LLM knows the information, or the gestalt, an organized whole that is perceived as more than the sum of its parts, or the main idea of what it's talking about. When this imperfect magic is not accurate or doesn't work, it's commonly said that the machine is having hallucinations. So scientists can only measure if it works or not, and in what probability. They will need more time to know exactly what's going on inside these models. In the meantime, they could be developing intellectual superpowers and we don't even know it. Scary? We just put trillions of shit inside these machines, and thanks to the lines of code that conform the brains or structure or neural network of these models, the thing is finding patterns in the vast amount of information, and in the meantime learning about how this language works and the content of the information. Okay, cool, we're done. Well, no. This magic neural networks by its own, it's not helpful. It is going to act like an internet document sampler, and this is not what we want. We want it to write us poems. The second stage, or the fine-tuning of the base model. The initial stage or training of the base model uses a lot of data. However, this data could be worth nothing because the vast amount of it comes from the internet. And we know that in the internet sometimes you don't find the best of the best. Stuff that is not at all high-quality information. In the second stage, they go for quality over quantity. Now we need to specialize the model or pre-train it for a specific task. Here we go, and without knowing it, we just found the P pre-trained of ChatGPT. You're welcome. By the way, the specific task is to be a chatbot for general purposes. How is this achieved? First, the company that creates the model employs individuals to have conversations with the model. These conversations have to be of high quality, created on labeled instructions such as be truthful, harmless, and helpful. These guidelines could be hundreds of pages, by the way. The company will specify how the model should behave. In our case, be an honest, harmless, and helpful assistant. Human evaluators label the chatbot's responses based on the HHH framework, popularized by Anthropic, to how helpful, honest, and harmless a model is. They have multiple conversations and fix misbehaviors in time. The model primarily learns from these new conversation documents. The quantity depends on the resources of the company developing the model. The corrections made to the first conversations are loaded as training data, so the model can learn what is correct and what it's not for the next conversations. If you think about it, it's like a very complex thing. Self-improvement usually happens when we have a clear goal or achievement. For example, win the chess game. However, in the case of language, it is very complicated. Everything is open to interpretation. A lot of people can say that this piece of text is amazing, and others can think otherwise. There's no easy way to evaluate reward criteria. Now, we train the model with these conversation documents. It learns to follow their style, which is mostly in a question and answer format, similar to a helpful assistant. Reinforcement learning from human feedback. If we ask the model any question, it will answer based on the form of the qualitative training HHH framework. A model that meets these standards must be aligned with human preference through human-generated data in order to meet the needs of users and businesses. Or, to make it simple, the model should match what people want, using feedback from humans to better serve users and businesses. Here we just introduced another term that we hear everywhere: alignment. AI alignment research focuses on guiding AI systems to follow human goals, choices, or moral values. A misaligned AI system, you know where this is going. So in one hand, we have all this information that we obtained thanks to a lot of amazing machines with incredible GPUs. All this information is processed and studied by the model, and then we fine-tune the model to behave as we want, as an honest, harmless, helpful assistant. Meet ChatGPT. I hope that this is useful. So let me tell you, all this information could be useless if you don't know how to use properly the thing. Click right here to know how to find ChatGPT, how to install it, and how to use it so you can take the best of it and make incredible things. Stay kind.